Today we have not even half of the class. Girish, can you check on that?
Yeah, sure, I'm checking.
Hey Shivank,
Yeah, hi Karthik.
I want to ask every time we have to work on this Databricks on notebook, we have to create new cluster.
Uh, Basically, it gets because you're using the free one, so that's the reason it gets terminated for you by default. But even if you want, you can just go ahead and you need not recreate the cluster, but you have to start it. So the cluster will not be gone for you unless and until database have done something, but it will be still there and you can just start it. I will just show you maybe once we start off.
Yes, the cluster is still there, but it is showing that it is not in.
It will show you in terminated state.
Yes, I mean green light is not there.
Correct, correct. That's correct. So basically, that's what you have to start. Because anyway, it's a free one, right? So they will not give you that much of privilege to work on it.
Yeah.
Okay, I think we can start now. Still, we have lesser people, but let's start. So yeah, this is what I was talking about, Karthik. So let's say if I come to compute, it will show you terminated. You can go here, and from here, either you can terminate and so on, or you can clone it also if you wish to. If it says to sort of edit, you can do it from here. And one more way is like you can come to your workspace itself. Let's say I go to a theme, come to this, it will get detached. Now you can come here and attach it again. Okay, looks like this feature also they have removed. It used to get automatically sort of start. Fine, then go here and create one. Once you have the paid one, which I have it actually with me, so there you have a setting for it, which is given to you. But here the problem is that you don't have any setting, which is you can set it up anywhere. Let me just create a step. Okay, all of you can also start your clusters because we will be using in our lab now. Okay, so let's discuss what all we have done in last class. So we started with Spark SQL. We understood the concepts behind it. We saw how the catalyst optimizer worked. We also saw internally how things work in Spark SQL. Followed by, we also noticed how to work across with respect to Spark SQL data frames. So we saw a lot of syntaxes around that, and that's where we had stopped. Now, in today's session, what I'm going to do, I'm going to walk you through some reading, writing stuff, how you create schema programmatically. So all those things is what we will be spending time today. Now, there is also one more thing which is going to be important for you, that sometimes when we define schema, we have seen it with dot schema. So we were able to do all of that, but now we will not be doing that way. We will be basically using a different method to do this. That's going to be maybe for 1.5 hours. We will be talking about this. The last half an hour, I will be spending on explaining you some concept, which is going to be most likely in your MLF, and followed by tomorrow we will be talking, we will be completing some demo in that, and then we will be moving to Spark streaming, and we will quickly see a demo around it. So that's basically going to be agenda, the way we will be proceeding further. So let this cluster be ready now, and we will be starting up. So today the first thing which I will be showing you is how to create a UDF. Now, if you recall, what was happening till now in when I talked in Hive also, I told you this thing, that if you don't have a function available, you can create it, and that's called as UDF. So you can create that function, and the function creation is only possible in Java. But when it comes to Spark SQL, you can write it in any programming language, which means you can also write this in your Python, in your Scala, or in any other programming language as well. And then once that function is available for you, you can do whatever way you wish to. That's one advantage what you get here. And that's a very powerful construct, what we have basically with respect to Spark SQL. Because now you can have your customized things the way you wish to. That gives you that power. Now, how we will be doing it? Let this cluster be created. Still taking time. Okay. Let this get created. At least we can see the code meanwhile. So first thing first, once this will be ready, I will be maybe quickly loading up my data set, which is again from the customer data set. So that will be my first step, which I will do. I'm not executing it for now because my cluster is not yet ready. Once it's ready, I will bring it up here. Now what I want to show you is how to create my UDF here. So let's say I have a date format, which I want to convert it to a different format. And notice I'm using Scala here. So what I'm doing here, I'm calling a function get customer birthday, which is going to take three inputs. One is your integer, second is your month, and the third is your day. And it's going to return and string as an output. The output is going to be what I'm doing here in Scala. Also, you can write like Java function, right? Because you can have this JVM involved here. So what you can do, you can say java.time.localDate.off. And inside this, when you will pass it, it will combine them and create it into a date data type. Now, once I got it like a date data type, I'm just returning it like a string. That is what this function is doing. Means I'm passing three arguments, which is my year, month, and day, and I'm getting a specific property. Though I have taken a very basic example here, but definitely you could have taken even a complex example as well, where you could have written a very complex code to help it out. Now, second thing which you can also do is when you have created this, right now it is just a function. So you have to convert it to a UDF. Now, how you will be converting it to a UDF here? So you have to just like how you typecast a variables. Same thing you have to do here also. So you will say, I'm going to create this UDF now. I'm going to typecast it as a UDF type with the same name as this function. And I have to tell that, okay, the first parameter is going to be integer type. Second parameter is going to be of integer type. Third parameter is going to be of integer type. Output is going to be of string type. So this is what you will be telling it up here. Now my cluster is also ready. So I can attach it so that we can execute all this code. So now let me execute this. Once this is executed, you can create this one, and you can also execute this one. They will all get executed once they get the cluster. Now, one second. There is some mistake in reading the data. That should not happen. Okay, there is a slide. No, if you notice, I'm using something called as customer schema. That is a mistake here. Okay, so what have happened is I have not defined this customer schema. This is being defined in a different file. What is this file? This file is being present. I have basically created a separate file. When you will start working, you can also, I will also explain you how you need to import this, because I will give you a DBC format, not the PySpark format. Now, let me show you how that will look like to you. So let's say if you will go inside your practice, you will find basically something called as schema declarations. So you can notice what I have done here. I have defined all the schema declarations here. Otherwise, recall what I have to do. I have to say that a dot schema, I need to define all the column names with the data types, right? In order to avoid that, what I had done is I basically created this sort of schema declaration here and sort of use it directly here. So I needed basically this customer schema. I can either copy paste or I could have executed this full file. Sorry. So what I can do here, let me basically copy this from here, because I can create this schema, come back to my notebook. Let's go to, sorry. Yeah. So let's go to from here. Let's go to home, user, F-theme, go to data frame. From this data frame, come down and somewhere just execute it. So now once this schema is available for you, go ahead and execute this now. So this is actually a little better way. In fact, I would say this is what being used also. I have also used this data file option. So that is also happening because I have basically called all this schema and all that. Let me do one thing. This is customer.dat only, right? Let me just quickly load it up from up. Otherwise, I have to recreate that whole file, which I want to avoid. Okay. So I'm just going to use info.schema. Let's use that now. Now, once this is done, now you can create a function. You can pass it on to this one, which is going to now create a UDF for you. Once your UDF is ready, now you can use it just like a normal function. Okay. So basically, whatever way you want to, now you can call it out. For example, you can say here your customer df dot select concat. Now, what you can also do here is, okay, this is what I was afraid of, but let me fix it. So we need to import this also. So I need to import these functions, and now let me execute it. You can see this output now. So look at this output, what I did here. So I define now my customer SK. I'm concatenating the name as total name. But notice here what I'm doing. I'm saying get customer birth date underscore UDF, which we have created here, right? So we have typecasted this function as a UDF type, and that is what I'm calling up here. And here I'm passing these three column next. I'm saying that, hey, you will be taking a year, you will be taking a day, you will be taking a month, and I'm going to call this whole thing as my birth date. Okay. So basically here you can see C underscore birth underscore date is a new column which got created. And here this is showing up in the format of your date type, like complete date type, which is like YYYY slash MM slash basically DD, right? So that way we have kind of stored this up. And you can see here that even the older values are being shown up. So again, this was a very basic example which I brought up in front of you. You could have done it even like a little complex way, but the main idea is that you can create a function using some other method and could have gone along with that. That is one power what you get with it. Everyone clear on this UDF component? Okay. Now, second thing which I want to talk about is if you want to write your SQL query directly, can you do that? Yes. Let's say I want to call this UDF uh, here as a SQL query, means as a SQL query. So now, in that case, what you have to do is, I have already explained you that create or replace temp view, right? When we were looking at the PPT. So it's just like a typecasting, creating like a temporary view or a temporary table. Let's call it as V customer. And now what I'm going to do with this, the same thing which we have created there, I am now going to execute it here with the SQL format. So now if I want to execute the SQL format, I just need to say %SQL, select, give the column names. Notice here what I'm doing, I'm again calling this my UDF which we have created, passing my column names as this from my V customer. We can execute this also. Now, okay. So what just happened here? Now there is a slight thing which we have to fix it across. When we are doing this, the one thing which have happened is that you need to even register it. Let me show you. So let's say I will come here. I will just explain you in a minute. Once this is executed, you have to execute it. And let's execute this. Now let me explain you what just happened. When you wanted to run it like a SQL query, the first thing is, though you have created a UDF, but now you have to kind of bring it to my basically to make my metastore, Hive metastore understand this, right? Because that is not being registered with it. So that's the reason what we have to do is we have to also register. We have to tell it, hey, this function I'm going to register, which is going to come from this function name, get customer birthday, which is taking these three inputs and returning as a one string. That is number one. Once you did that, then after that you have created from this basically one as V customer. And after that, when you will bring this up, since this is registered, so it's like you are making it available now with your metastore, you're registering it with them. So once now the metastore will understand it, then when you will hit your HQL, it will work for you. So that's one slight difference when you will be executing this up with your HQL directly. Everyone clear with this component? Any questions? This is little advanced concepts in terms of when you will be working across with this. But at the same time, you will be finding this a lot basically used in your coding side. At least if you ask from my practical experience, I am using this a lot. This UDF things, I write it a lot, specifically in Spark SQL. And in fact, I do in this method only. There are other methods also, just to be making you aware. There are other ways also, which these are like same thing, but just that if you want, you can use them as well. But what I generally prefer is this medium, the way I have shown you up. That's how I have written this code for you. But at the same time, this is something you will be writing a lot, especially if you know Python or Scala. Now you already know Scala. So you can now write it in Scala. So very easy to do that. If you know Python, you can also do it in Python. No issue with that as well. So that is one advantage what you will be getting when you will be writing across all this. So definitely I leave it to you whether you how deeply you want to go with that. But it's simply I would suggest you that though I'm not going to ask you to do this practice now because it will take up a considerable amount of time because it requires coding and a lot of things around that. But my suggestion would be once you go after this class, review it in this way, create maybe a new function. Right now we have done it in this way. Maybe you create something else. You say that, hey, I'm gonna create a new function which is going to be first of all going to create the name and the last name as concatenated with basically everything as lowercase concatenated with the year of birth at the rate of gmail.com. Okay, so let's say you want to create an email ID of these users And these email IDs basically will be something like this: first name dot last name in all lowercase, concatenated with basically your year of birth and at the rate of gmail.com. And let's say you want to do it with PySpark or with Scala. So kind of create that. That will, if you once you will write the first one, do it with both. Do it with Spark SQL, do it with the SQL web. When you are able to do that, you will gain some confidence that see it is all working for you. So this you can take it as a homework activity. I know it will take around half an hour for you to do that because it's the first time you will try it out. So that's the reason we are not doing it in the class. That's the only difference. Everyone clear on this part? Any questions first of all on this? Okay. Now, what is the next thing I will be doing here? So next thing is, let me show you one more stuff, what we will be going with it. Let's say I again hit this command to read customer address.dat. Now, if you want to see the result, you can just say basically whatever this data frame is dot show, right? This we are well aware of. There's nothing new here. Now what I want to show you is, remember we have seen so many commands there as well when we were looking at so many things across from Spark SQL way. So the same thing you can do it here. So like if you want to just create temp view, which is little different syntax from the last one, that also works. So this is also the syntax that works. There we have seen create or basically if you look at this one, this was a little different, right? Here. So here, create or replace template. Here, I'm creating create template. Both syntax works. There's no difference with that. Only difference is here, in case if it's basically already there, then it will sort of ignore it. There, if it's there, it will override on top of it. Okay, so that's going to be one difference here. Now, if you want to view the records in the Spark SQL way, you could have just done like this, like select asterisk. This syntax we have already seen. There is nothing new inside that. Similarly, when you want to run your HQL queries also, so that also you can do it quite easily here. So like you can do something like Spark session.sql and you can say select asterisk from your temp view name dot show. This will also work for you. So this I'm just showing you some older syntaxes which we have already seen it last time. You could have even written it in this manner also. So you could have said that my data frame name dot select, and I can define some column names. I can define some conditions, and I can also say that, hey, create my temporary view across with it, right? So this is going to create basically a data frame which is going to be accordingly going to be converted to a temp view, which I will be calling it as VAT underscore address. So from this data frame, I'm basically creating this temp view having both these conditions. So this is also one way you can go across with it. And if you want to see this result, now let me show you one interesting thing. I can simply write my SQL query like that. I can say select asterisk from, and I can define my temp view. You can see I'm not doing anything. I can simply write it from here. Okay, I did some mistake here. This should work. Not found value select. Okay, let me just look at this. This should work. I'm not sure whether this is versioning thing or something because I'm 100% sure I have tested this 2 days back.
Shivank, we need to use percentage SQL before writing the command.
It actually worked without that also. Percentage SQL. Surprising because I can show you this will be there in my notebook. I think I wrote it here, the same command.
Here we have selected SQL on top, right, Shivank?
Oh, see this one.
While creating the notebook.
Correct, but can you see this?
Yes,
Okay.
I mean default one is SQL here. So.
Yeah, so here you can see I was not using, but anyway, maybe these are just small syntaxes thing. Because this notebook I just created 2 days back for you guys. Nothing more than. So I remember each and every command which I've written here. Okay, anyway, so now you can just say %SQL and you can basically define all this and it will give you this result. Fine. Now, once you have executed all this, you can even write any sort of SQL command of your wish. In fact, let me not waste much time on this. I can show you from here itself. Look at this one. So you have like a lot of commands here. Like you can say select history from this, show databases. You can also execute like what is my current database. You can see that I have even put down one more file called as create underscore retailer underscore db. Let me show you that also. What is this I have put down for you? Inside practice, I have put down a file create retailer underscore db. And here what I have done, I created a database. I created some tables for you. Okay. Reason being this, basically this is all which either I created directly there or since I'm going to use it quite frequently, that's the reason I separated it out. And that's always a good software development practice also. You should always keep this in mind when you're developing something that you should follow some good software development practices as well. So now if I come back to my Spark SQL 101, now here, what you are supposed to do is like you can see here that you have all these commands. So my suggestion is that you can take a look at this file once I will upload it. Once I will complete this topic, I will also explain you how you can bring it to your environment. So it's all SQL commands. I don't want to go into this in depth. Reason being, all this you are well aware of from the Hive itself. It's just that I have shown it here. I will upload it for all of you. Go ahead and use it and basically ensure that you know each and everything. For example, you can see these options can be provided in create table command also. So these are very simple to understand, like what is sum, what is average, what is mean, right? So I don't want to go into all these things probably. I will give you this, you can just start using it. Everyone clear on this part? Okay, sure. So I will keep this up as an extra part for you. That's the reason I created all this in depth, but I definitely wanted you to basically use this at your own time frame because this is just for your practice. Now, few more things which you have to do once you will get this particular notebook. Once you will get that, look at the Hello Spark also. Data frame 101, 102 also you can look at. I have also added some activities, small activities inside that. Make sure that you do that. Don't just miss it out. This will help you, and this is a very simple activity. If you understood the above part, anyway, you can see here, I'm just doing some filtering based on some birth month, right? And based on that, I gave you one question to solve. That's it. So just practice all these as well if you want to make these things perfect for yourself. Okay, I'm just holding here for a few minutes. Any questions from anyone? After that, let me go back to my screen again. Any questions?
So Shivank, we can access your workspace. We can access all these notebooks.
No, I will tell you how to upload this notebook in your own environment.
Okay.
I will give you a zip file. You have to unzip it and upload it just in one go, and everything will be available for you. The same one.
Okay. I also wanted to ask about the temp views which we just talked about, right? How is it different? I mean, if I can correlate it with data frame or something, is it
It,
more or less the same thing, right?
it's the same thing. It just you can think of it like a typecasting.
Typecast.
So just like how sometimes we read the data from a file, it is read like a string, right? And when you typecast it to integer or something, then only it starts working from your code perspective. Similar way you can think of it, this is also a table. Like from the data frame, we are just typecasting it to the table type now, which is sitting into the RAM. Okay, this is also sitting inside the RAM, but it just kind of a different typecasted way, which your HQL understand.
Okay. Understood.
Any other question from anyone on this?
one more, in the RDD side, we discussed two types, right? Value and the variables. But till now, we have been working with values.
VAL you see mean?
There were two things, right? If I remember correctly, we had VAL and VAR in the beginning. Not here, I think 2-3 class back, when we were talking about RDDs, right? Let me check my notes. But I remember we talked about two different types. Value which will be overwritten, which is like
Got it.
parameter maybe, and then variable which are like which can change.
These two things, correct. So what's the question?
So we can create RDDs even with var, right? Depending on the scenarios.
You should not. You should never create it like that, because the RDDs are supposed to be immutable. So it will work, it will not throw you an error, but in lot many operations, it will end up with problems.
Okay. So any particular scenario where will be more preferred than value?
We should never, if you're creating an RDD or a data frame, never create it like a mutable object. It should always be immutable object.
Okay.
Okay? So you should never do that. Okay. Any other question, guys? Okay, so everyone good till this time? Perfect. Now, the next thing which I'm going to walk through, I know I did not give you the chance to practice because the UDF, UDF will take time, and anyway, this was just a simple SQL commands. But going further, now I will give you some options to practice as well. So wherever I feel it's going to be important, that's where I will be bringing up all these things for you. So now the next thing which we are going to discuss is so how to deal with when we have different types. Like one way we understood about schema right now, but there are some other methods as well to deal with schema. Let me show you how we work across the time. So first thing first, let me start with reading a file, which is going to be like this, right? So this is what we are aware of. We have seen already that I can define this dot schema and can go about it, and we can define all these options and everything well. Right? This is we are well aware of. And if we define the schema, it will show me the schema also accordingly. Now there is also another way which I want to bring up is, let me first import this type. Now what I will do, there is something called as struct type. Okay, so you can define it. In fact, even if I show this here, household underscore demographics dot schema. Let's execute this also once. Look at this one also. Internally, the schema is always stored like a struct type. Though I have called it with schema, but notice struct type is the major parent type. Within that, I have struct field. For example, I'm saying that, hey, my HD demo SK is of long type, and which is allowing the value of null. Similarly, HD income band SK, which is the second one, this is also of long time here. You can see here also it's defining it as long time. Now, instead of this getting created, I could have directly created my schema also in the same way. You can notice this is exactly the same thing, right? I'm saying that struct type, let's create an array where I have some column names, which is going to be of long type and value of null is going to be true. Then this is going to be again struct field, which is going to be the column name. Again, this is going to be of long type and the value is going to be true, right? So I can also define it in this manner as well, instead of having this in the default medium. Now, how I will be using it? So I'm going to define it as, let's say, HDS, right, which is my schema here. Now, what basically we can do here? So here, if I have to define this schema, I will say that spark.read schema. And basically here, if you recall what I was doing, I was also calling schema, but I was giving all these values. But here I simply say HDS now. So I have, because defined all this struct type and struct field, means every column and the parent type of it. And then remaining things will remain the same. This also is a method to follow it up. In fact, this is the preferred method as well. Because if you read it in this manner, the when you are reading it up, it's more clear. Because when you have larger amount of column and if you write it like this is not the preferred method. Okay, so that's the reason it is always a good idea if you basically pull this up in this manner of defining the struct field separately and then work on top of it instead of basically doing any operations in this manner. Everyone clear on this part?
So Shiva, is struct type a Scala function?
No, this is also available in Java. This is more related to Spark.
Okay.
Everyone clear on this part? Struct type, struct field, again a very important construct actually. That's the
Do
reason
we have do we have something similar for Python?
yeah, in Python also you have something similar.
Okay.
Okay. So, but yeah, not exactly same. Maybe I can give you the syntax. You can run that as well. That's fine. So this is the first thing you have to know that whenever you have to work with the struct types and all that, how you will be creating your columns and being working with it. Okay. Now, what I want is not with this one. Let me go up because this anyway you guys have already seen it. So it's of no use. Okay. All of you, can you go ahead and for this customer.dat data which we have created, right? I think this is for customer.dat only. So customer.dat data which we have created, you already have the schema. I can pass on this to you so that you can very quickly follow this. Create a struct type from this struct type struct field method and quickly create a table with that, maybe the data frame with that. I'm just sending you on the chat so that you need not spend time typing the column names and all. But the main practice is to look at how you will be sort of creating the struct type and struct fields. Quickly work on it. I've already sent you the schema and you have to do that
Cannot
on
copy from the chat, Shivang.
you can't copy from here.
No.
Then just create some smaller names for it and just create that. Anyway, this is in the chat, so you can just refer it quickly then. The syntax of this is in front of you. Once you're done, send me a code. Anyone have completed this? Last 2 minutes. Done, everyone? Or if anyone is facing any issue, please ask me. Main idea is to just follow whatever column you want to provide, you can give it. Main thing is to keep giving the correct data types in the same sequence and keep on giving true if you want to put a null value. In case if you think that you want to restrict it with non-nulls, you can also do that. Now what I will do is I will show you some of the commands again from the notebook which I have already executed. And this notebook, I will give it to you anyway. So you can execute it at your end later, but I will explain you about this notebook. The important things are. So the idea in this notebook, guys, I need your attention back now here. So the idea here would be that what we want to do is that there are different data types and every data type have its own functions also given in Apache Spark to get to know them. Now, definitely we can keep executing the codes. It will be too much. That's the whole reason of bringing up this part for you so that you can at least be able to see. I will give you some commands to execute also. So keep this household demographics.schema with you because this is something you will be using it up. Now, or I will copy paste this command for you, maybe in Google Drive. Now here, what we will be doing is, we have already seen this lit command, right? So if you use this lit command, you can directly input whatever values you have. There is no problem with this. Second thing is, we have also seen how to deal with the filters. So again, I'm not going into that. We already well aware of where order by will just sort the values for you. Again, this is just a function to be aware of. So I will be mostly spending time, which is little tricky in nature. Trim function also we are aware of. It will remove your spaces around. So I'm not going with it. We are very well aware of with columns. So right now, these functions are related to string. That's the reason we are aware of them. I'm not spending much time over them. Look at this one, sales stat df. Now what I'm doing here is basically in this case, we have created a web sales DF, and from here we are basically creating all these columns from it. We are showing it up. It's all good. Now look at these ones. Here we can also have some mathematical functions like expression. Like you want to perform some mathematical stuff, you can do that. Let's say you have some float value, which is 23.23. You want to round it up. You can also do that. So these are just some functions for rounding and all that. Again, not that tricky. We can easily do this. Now, even this count functions and all are we are well aware of. I'm not going to spend time on it. Length function, it will tell you the number of characters in it. Distinct, we already know. Let's see some interesting functions. Lower uppercase, we all know. So I'm just going to spend time on the ones which are going to be critical. For example, look at this one, date functions. So now with date functions, we have a lot many. For example, this is a string. We just use the literal to convert it in this pathway in this particular data frame. And now we are saying that convert it to the date type. It will all be, when you will do the print schema, it will show you the date type. Similarly, you can see we are all converting here. Even here, you can convert it to the Unix timestamp format. So we can define the even the patterns as well. For example, here, if you will do it, it will give you the year, hyphen, hyphen, bye. But if I want to change the formats also, we can do it like this. Or we can do it in this manner also by using the _date. Similarly, Unix timestamp or from Unix timestamp also have the same way. It just that it will also show you the number of hours, number of seconds, number of minutes. So that is what you can also do it. So this is about how to play with your date types. Again, these are just for expressions. I'm not going to that. Again, these are very straightforward, simple ones. Create temp view and all we are well aware of. Explode also we have already seen in Hive. So nothing to go about it again. It will just bring all the values separately. Here you can see some functions, but again, you have to practice all. Though I am giving you all this, you have to practice all. Now this is important. Here what I want to do is, I want to drop some null values, missing data. A lot of time in my data sets, what happens is we have a lot of data which is sort of missing. So for that, I have something called as na.drop. So if you use all, it will be dropping basically all the records which have the missing rows. So all the missing rows will be deleted from it. You can do a count and check all that. It will all be fine. So you can see this .na.drop is going to remove it. Now, this is another interesting function. If you do a na.fill, what this do is, so in case if you have a missing data, you would like to replace it with a missing value out of it, which means that some other values out of it. You can easily do that by defining this, like whatever comes up, replace it with this. Okay. If the column name is birth year, then replace it with this. If the column name is birthday, replace it with this. Like that, you can define something, whatever you want. So this is one way to play around the missing data. And if you recall, I've already explained you in last class that how to check the missing data. In fact, we have run some queries on that. But this is basically to drop it or to replace it with something else. Generally, what we do instead here is that whenever we are executing these commands, we first look at how many missing data we have. So let's say we know overall number of rows, then we see that how many missing records we have. Then based on the missing records, we do some analysis. We see that whether those missing records, what we have, what basically how they looks like. We do some data analysis on that. And depending on that, we take a call. Either we should be replacing it with a mean median mode. Maybe if it's a character string, then you can think about mode. Otherwise, you can think about median, depending on your problem statements, what you're working with. And once you have this, both the things stuff with you, then after that, you sort of go ahead and replace it with that or decide to drop it. So whatever way you want to, you go with that. This is the general way any data scientist works. People who are working on PySpark, they will be, sorry, I'm saying PySpark, basically on the data science stuff, they must be very well aware of this thing, that how critical this is to ensure that you do not have some corrupt data or the missing data across. So that is going to be important. So what this notebook will help you is to just look at different functions. Definitely, though I have put down a lot many functions for you, but it's not like it's a complete list. You can even go and look at some Spark links as well. I have given it here also. At few places, I have given the links. You can go to this documentations and can also read about all these functions in detail. Okay, so you can always read from here, but definitely majority of the functions which are very frequently used are already provided to you here. So at least for your practice, this will be much more than enough. But make sure that you practice. Okay. Unfortunately, we cannot do everything in the class, but I want to ensure that you have at least the maximum things with you to practice out. Now, so this is about your dealing with data types. Any questions first of all on this? Any question, guys? Okay. Now I'm going to go towards the reader-writer APIs, what all we have. Now, what happens is when you're working with respect to your data frames, you have so many things around that. You can read CSV format, Parquet format, ODBC, you can read it, ORC format, right? So many formats you have. You could even use so many APIs to get it done. We have seen so many methods from the read perspective, which we can always use to do that. We have also seen how to deal with the struct types to kind of also write all the schema, and we were able to see all of the records as well. Now, after we have seen all this, a lot of times you can always happen. It always happens that sometimes we do not know which schema will work. So you have to also sometimes do experiments. Change a bit. Let's say sometimes you started with string, then you thought, okay, it should be long type. This is something I'm just telling you because we do all these formalities a lot of times. Now, when you're reading a schema, a lot of times one challenge which comes across with it is that your data sets which comes to you is not in a good format. What I mean by that, basically sometimes we have the corrupt data in middle. Maybe I'm reading it like a long type, but maybe I have some corrupt data. So default nature is it will just place null instead of that. So what I want is maybe if I, while reading the data, if it finds, let's say, some bad records, instead of replacing it with null, I would like to drop it. Means while reading itself, can that thing happen? Yes, you have even those options as well. If you ask me, in practical word, this is what we do a lot. Okay. Sometimes we definitely don't want to go with the default mediums. We want to definitely ensure that we take the appropriate actions for them. So for example, we can see this one. What I'm doing here, I'm reading the data household demographics underscore m.dat. And what I'm doing here is I'm saying drop man form. Now what it's going to do for me, this is going to ensure if I have any sort of a bad data, which is going to be available, I would like to drop it out. Okay, so that is what it will do. Now, what I want all of you to do is, let me execute this. What I want all of you to do is, okay, just make sure that you get this HD schema. Let me get that. I must have this file. Let me create this. I'm just going to place it here itself. It's anyway a very smaller one, so that I can define all this data type. Okay, now it's working. So what I want all of you to do is, let me give you this in your Google Drive so that you don't struggle. I don't want you to spend time in writing code and all that. Okay. So what I'm going to do, I'm going to give you this schema here, number one. So what I'm going to do, I'm just going to write in your Google Doc the schema so that you don't have to struggle with this. And second thing is I'm also basically rest of it anyway you can write it on your own. You have to just use this path to get this file. I'm also giving you the path. I'm giving you the link quickly. You can directly click on this link and reach there in the chat box. Can you all come to this doc? Okay, I've already given you the schema. Now what I want is try to do this first without drop malforming. Okay, do a count of total number of records. Do it with the drop malformed. Then count the total number of records. Tell me what's happening in this list. So as a data scientist, tell me what's basically is going to be the result in this format.
Shivan, can you repeat that again?
So I have given you the document link which had the schema. You can go and copy from there, as from the chat it was not working. So what you have to do, this will be copy, you can just copy paste from there the schema. So one is you do it without mode, okay, create a data frame, count the total number of rows what you have. Then do it with the drop malform and then count the total number of rows and tell me what is the result for you.
Okay, sure.
Once you are send me your final results. Since I have copy pasted the code, it should be quick.
Shivang, for me, it is giving the same number of count for both the methods.
Now, can you go and do some analysis on this data? That's the second thing which I wanted to do. I just gave you a very random table. I didn't look at it, whether it had malformed or not. So look at the data once.
So it has actually some in one column. It has some values like unknown, which otherwise should be a range.
Then it should have pulled up and send it across. Then again we execute it. It will work in that case. In fact, do one thing. Just change this mode to fail fast and tell me what happened.
Change what to fail fast?
Good. Drop malform to fail fast.
For the drop fail fast also nothing happened, like it was same.
What is happening is it's not treating unknown as the malform data. So
Yeah,
you can
same here.
if you insert, let's say, some spatial characters and all that inside your data set, then it will treat it like a malform data. Otherwise, it's just treating it as the same data type. So let's say if you have an integer, it will convert it to like that. So you can also play with this part. Change this HD by potential to string from long type. You can see I've written this down also here. Basically, once I've made it long, you can change it to string type again and then try that as well. So it also depends on the data type which is there. If it's able to read it in a way it is able to convert that, it will not treat it like a malform data. What fail fast also do for you, I just gave you this difference. Fail fast basically means if it finds any sort of the malform data which sparks since it's malform, it is immediately gonna give you the runtime exception. It will not do anything. It will not take the default method, which is called as permissive method. Default method, what happens is it just convert the value to the null record. That was the default method. Drop malformed, I've already told you that it's basically if we do not match, it will remove those records. Fail fast will abort. Simply, it will give you runtime exception. That's the reason I asked you to give the fail fast. If fail fast is not giving an error, that means because of the data type, it is able to treat it in the right way. Okay, treat it in the right way. So you can always change these data types. Maybe if you think that you have a long type, make it maybe date type. Okay. And then see if you try the fail fast, immediately it will fail because it will not get the date type, it will fail immediately in this case. So you can just change the data type and play with it. You will start seeing the results across the time. One more thing which I want to also tell you is, just listen to me. This is also going to be important. This is again keeping some time frame in mind, which we have to kind of look in some time frame. So one thing we have just understood about this, but a lot of times what happens is when I get a bad record, I want to view them also because I want to make sure that if there is anything by mistake have come in, I want to watch that. So what I can always do is I can say schema and I can define this bad record, and this bad record path, I can define a path where I would like to save this bad record. Means whatever the malform information is coming, I can save it in this location, and the actual record is anyway coming from here. So what you can do is now, once you have saved it, you can do the fs ls part and can check in this location, and it will also show you all the records which are basically coming up here. So that's also something you can try later, that how to basically deal with the bad records path and so on. So this is very good. Actually, this gives you a very good insight to look at the data which sort of got have failed around it. Okay. Now, okay. First of all, everyone clear on this part? Whatever we have discussed. So you have two things to try. Maybe you can do that after the class and we can discuss it tomorrow with me as well. So one thing to try is, when you did that, right now everything was in the right shape, though the unknown also it had read it properly, didn't give you error. What I said, change the data type to something very weird, maybe date data type, maybe make it, if it's a string character, make it maybe integer, make it very weird data type. When you change this data type, definitely it will become malform because string it cannot convert to float or something, right? So now in that case, you should start seeing the malform records. Now you can do three operations. One is the default operation, which is called as permissive operation. Don't do anything with that. It will basically make everything as null character. Second operation, I told you already just now that you can basically define it as drop malform. It will drop your records in that case. Third one, I told you fast fail. So in this case, if it finds the malform, you will start seeing the runtime error. So these three things you have to try, number one. Second thing what you have to try is, when you are doing this step, add this bad record path into it. So now what this will do is, it will, whatever records it is dropping or basically it's throwing the runtime exception, whatever. So because of whatever record it have happened, it will save that record into a particular path and you can watch it after that. So these are the two things you have to try maybe after the class. Okay? Again, keeping some class timings in mind because I have to start a new topic also today. Okay. Now, second thing is, when you're reading this, I just want to tell you again something from my practical experience. A lot of times you will get the data like a JSON record. And the problem would be that JSON record, what you will be reading it up, you will find a lot of issues in this. Like you will struggle a lot in kind of giving the data sets and so on. So the way we deal with it, like for example, you will see that this date, right? Now the date, the default format from Spark is that it will read it in the format of DD hyphen, not dot, and so on. So how to deal with these situations? Meanwhile, reading itself, can I take care of this part? Yes, you can do that. So the way you can do it is, in the options field itself, you can define all this. So what you can do here, you can say here, basically spark.read, you can define your schema, whatever you have, and you can define your format as JSON. Notice the options, in the options itself, I'm basically defining my date formats and all that, which will take care of the things for me. So again, this is also a very useful step. Keep in mind that how you can go about all this and can read all these records as well. Everyone clear on this part? Again, these things I'm just going little extra beyond. Reason is, again, I have seen when I work in projects, these things create problems. That's the reason I just brought up these examples for you so that you're aware of it. Okay. Otherwise, we could have stopped this actually long before Spark SQL. We have already done quite enough. But this is just for your reference so that you're aware of, when you work in your projects, what kind of issues will fall for you. There is also one more thing. A lot of times you will have nested JSONs, right? When you get nested JSONs, then again there is a problem. For example, let me show you this one. And this is very practical issues which happens. Look at this JSON. So here you can see, though I have birthday, email, all this looks fine. But in nested JSON, I have an address. Inside the address itself, I have a city, country, state, and so on. Right? That kind of problem I also could have. So it will look something like this, right? So maybe I have all the JSON records were good. Like I have birthday, and here I was writing some records, which was all okay. But maybe as soon as address came up, inside address itself, I got some more records. Like inside this, I got city and so on, right? So basically, it became a multi-line sort of JSON problem. How to read this up? If you will try to read with a normal format, again, you will end up with some problems. Spark will not automatically be able to do that. And trust me, this kind of data set you will get a lot, especially if you're getting in the JSON format, multi-lines comes a lot. So what you have to do in those cases, make the option of multi-line as well. Okay. Otherwise, you will keep thinking, what's the error I did? Why I'm not able to convert? And a lot of issues will end up again in this case. So make this multi-line as true. Then Apache Spark will immediately get to know that, okay, I have some nested JSON structure. Then it will read the schema in the right way and you will be able to go about it. Okay. Clear everyone on these parts? Okay. Now let me show you a few more things with respect to write, that how we perform the write operations with it. Now, if you want to do a write, just like you have the read, you have the write also, right? No difference with that. But let me tell you, though I can give you a simple sentence, but let me tell you how we generally do it. Just like in Apache Hive, right? In Apache Hive, we were doing the partitionings and all that. Similar thing, you can do it here also. When you're writing it up, this will give you a better way of going about it. For example, here you can see that I'm saying that you have to write format. I'm giving the mode as overwrite. That's number one. Like if it's already exists, go ahead and overwrite on that. Then we are giving this path, basically where I want to write options, header, compression as snappy. Basically, if I want to compress it also and keep it. But look at this partition bar. This is very similar to what we have in Apache Hive. Okay. So in this case, if we have a single data set, which is pretty huge, you want to divide it into different directories, you can do it in this way. If you don't want it partition, just remove this partition by. Everything will work in the older method, the way we are aware of. Okay, clear on this part also, everyone? Okay, now, few more things. Sometimes when you get a data frame, you want to see that how many number of partitions it has created internally. So for that, what you have to do, if you will try to get the number of partitions directly on data frame, it will not give you. There is no method for that. So what you have to do is you have to convert it to an RD like this and then say get number of partitions. So what it will do is it will tell you quickly that how many number of partitions you have in your particular data frame. Okay. So that's again kind of a very helpful thing, what you want to kind of provide. And one more thing which I have found it specifically helpful. If let's say you have a data frame, you want to save it like a Hive table, okay, inside like a Hive table. Though we have learned in Spark SQL also how to go about it, but there is also one interesting way. You can say df.write save as table. Give the name of basically the table what you want to. It will go to that particular database of Hive and will create this table for you. So again, this is a very nice way. In fact, this is something which I prefer it more often. So that's what you can also try to look at as well. Everyone clear till this point? Any questions? Any questions, guys? You can ask me now. Okay. So this is it about your Apache Spark SQL. Few things which I have talked in the last is more or less for your help when you will work in your project. I just don't want that you struggle and keep searching around. So that's the reason those things are there. The notebook which I will provide you may have little more than this, but everywhere I have given proper comment for you. So nothing to worry about. You can go ahead and start using it as per your wish. So you will not struggle around anywhere. You can easily understand it from those aspects. At the same time, when you will work on your projects, there will be something or the other keep on coming new as well. You can always look at the official documentations and you will be good with that. Number one. Now, the way we will be working and bringing the notebook here. Okay, before that, any questions from anyone on anything related to Spark SQL? We have spent a good time over it, almost more than 2.5 class, sort of to go over that, because this is again a very important concept. I hope everyone is clear how to directly write a SQL query, how to work with Spark SQL, how to use reader and writer, what are the methods within reader and writer which will help you out. We have also seen even how to look at number of partitions and so on. And we saw how to create a UDF, which is very good in comparison to Hive, because here we can write in Scala or Python as well. We saw all these methods in depth. We went across all the exercises and have executed each and everything. Any questions on any of the thing we have discussed? If you will cover my notebooks well, almost 80% of your project work will fall from these APIs only. 80%. So you will not find anything new kind of popping up for you. So do this practice well. Okay. So that's going to really help you out. Now, second thing is how to bring the notebook now. I will be giving you a zip file, number one. Okay. It will be a zip file for you. Now, what you have to do is you have to come here. That zip file name will be Databricks_Apache Spark fundamentals, something like that. Now, what you have to do is in your workspace, come here and click on import. Okay, click on import. Now you will see that it will give you this option. What you have to do here is you drop your file to basically to upload here. So you can see it is going to accept all these formats, either the .dbc, .scala, .py, .sql, .r, .ipynb, .rmd, .html. I will give you in the .dbc format, because in the same thing everything will come up. Okay. So what will happen now? Because of this format, it will just come here and will get uploaded for you. And once it will be uploaded, it will show up here. That's number one. Now let's say you did some code. Let's say I did this FIN code. Maybe here I could have added some more notebooks also. Okay? I could have maybe added maybe one more notebook. Let's name it as demo. I want a Scala code. My FIN tester is this. Maybe I could have written here also some code. Right? Now you can see that FIN have 2 notebooks. Just like here, I have so many notebooks. Right? Now how I could have stored it? I could have come here, could have pressed export. Now you can see only 2 methods are supported right now. One is you can create a DBC archive. That's what I just said, that you will get a DBC format. It will not be IPYMD. Second is the HTML format. Right? If you want to give it to somebody to read, you can also do that. So I'm going to give you from here. So if you just save it from here, it created like a zip file for you, and go ahead and save the record format. Okay. So this is the way you will be importing the notebook, which I will be giving you. Rest of the part I have already explained you. From the data, how you can go and bring your data files. This we have already done. We have also seen how to bring the images as well here. But this was related to your workspace. So you have to bring it from your workspace again. Again, just quickly telling you, click on import. Just drop your file or just browse it to that DBC one which you get after unzipping it. Click on import. Full folder will be available for you with the code. If you want to, you have written some code, you want to save it. For that, you need to go to export and save it like a DBC archive. Clear, everyone? Any question on this? How you will be bringing these notebooks and all? No? Okay. Let me do one thing right away. Give you this notebook file. So that I want to quickly check if you are able to do it also or not. Retailer.zip I have already given you guys. Just want to confirm.
Yeah, Shiva.
Yes, Shivang,
Yeah.
got.
Let me just give you this file also. In fact, I'm not going to give you the zip. Let me give you the direct DBC. Can you all go inside your Spark SQL folder quickly? In fact, I can give you in the chat. It's linked directly. Can you download quickly this Databricks underscore Apache Spark.dbc file? All of you quickly do this. Come to your Databricks. It's just a 2-minute process. Let's do it right away, just to confirm you're able to bring it. Go to your workspace once you have downloaded. Do that import step. Tell me if you are able to see all these files after that.
So other than transformation action, I can see the rest.
You can see the rest, right? Everything. Yeah, ignore the transformation action. I actually sort of were writing something, but I just removed it later. So this notebook which I have given you have everything. Transformation action is more the stages and those things which I've already explained in the class. That's the reason I decided to remove it. Okay, I will give you one more. That will be your 5 case studies along with the solution. Okay, I cannot cover in the class because again of the time constraint. So I'm giving you these case studies to work on basically on your own later. Okay? So you have to solve it. Make sure that you solve each of these case studies. If you do that, that will make your Spark SQL concept very, very strong. Let me upload it. Okay, I have given you 5 case studies, upload also. You can download it later and do that. The same method you can apply. Okay, so this is, I leave it to you to try it later. Okay, it's not something you have to do immediately. Now, one quick point. Okay, we are done with Spark SQL. First of all, any questions on this? No? Okay. Now, we will be moving to our next topic. But before that, I have few things to bring up to make you ready for your last class. Number 1. So if I talk about this portion, the first thing is talking about, so basically what we are left with, we will be talking about MLA. I will give you some reference right now on this so that you get some idea about this part. Followed by, we will be discussing about Spark streaming. Another component. This is we have to discuss. Now, once we will be done with the Spark streaming component, we will be discussing about the Apache Kafka. Okay. Now, to give you the context about even this Apache Kafka, there will be few things we will be discussing. One is the normal Apache Kafka, how we create few things, how to bring the data and so on. That's fine. There is an advanced concept called as Kafka Connect. Okay. Now, one challenge I have seen in this Kafka Connect is that there will be a lot of things you need for this. For example, maybe I want to send the data to Elasticsearch. Maybe I want to send the data to PostgreSQL. Now, it's not feasible for you to go and start installing either in your local system or maybe even to your VMs also, because it's tricky to get all those things installed with the right version and everything now. So for doing this, I will be using something called as a Docker. I will be giving you a Docker image. Okay, that Docker image will be having the Kafka Connect, Elasticsearch, whatever you need will be available inside it, so that you don't need to go and set up anything. I will give you that image path. You will be able to download that image for you. Now, only thing for this one is that you need to have a Docker installed with yourself. So can I expect that before Saturday class, all of you can go and install a Docker with you? You can also just look at the Google just to see what, based on your own operating system, that how to install Docker. And you can get the from your IT team this Docker being ready. After that, I will tell you within Docker how to work and all that. I will give you some tips. Don't worry about that. But in your system, please make sure that you get a Docker. And also ensure that you have minimum 4 GB of RAM. Okay. Otherwise, don't do it. It will just a little heavy and it will be otherwise creating problem for your system. But if you have 4 GB or above, it's all good. No problem with that. So this Docker image is something where I will use and will show you how to use this Kafka Connect. So that's important thing. The reason I told you now itself, so that you still have 2 days to talk with your IT team in case if you struggle and you need to get a Docker. At least by doing this, you can perform any of the activity within Docker and you can do it. And not only this, even a lot of times what happens is, anyway, this image I will give you with this. A lot of times what happens is in your company also, let's say, like if you ask me like an example, when I'm working with Facebook, what these guys have done is they have given me a Docker image. So what they have done, they have a lot of setup. They have Presto setup. They have basically a lot of things within there. And what they've done is they have given me a Docker image. Just to give you an insight about Docker, you can think of a Docker just like how I give you VM, right? Which you have just put it on basically on the virtual box. It is little better than that. What is the concept? Maybe I can talk about on Saturday in just quick 10 minutes or so. But for now, think of it that a Docker is just a machine where everything is pre-installed for you. Just think of it like that for now. Okay. So now what they've done is whatever they have set up, all the setup they gave me in the form of a Docker, and I don't need to do anything. I just use the Docker, create a container, and start working with that. That's it. So I do all the development activity. When I finish my work, I again create an image, upload it for them. They start looking at it on that respect. So a lot of companies do that. I just gave an example of Facebook because they kind of, even within their group also, they also do the similar method. Even this will be helpful. The same method you can adopt internally also. Like somebody doing some job, maybe one person have set up, give it in the form of a Docker, and other person can start using it, whoever want to reuse that. So that's one advantage what you get with the Docker image, because now you need not worry about a lot of stuff. That how you will be setting up, you have the configuration issues and all that, everything is gone, everything is taken care. It makes the development very fast. So since in Apache Spark also the same thing can come up, it's better to start knowing about Docker as well. Because maybe you can also have Hadoop, Spark, everything being a part of Docker, and Docker also don't eat much RAM also. That's a very good thing about it. It do it, but lesser than your VM company. Why? I may be telling you on that day or Saturday. Okay. So that's one thing I am expecting from everyone. Is there any concern in this? Let me know right away. Girish, if I ask you, that will be visible.
Yeah, Shivang, if you can send me some configuration related to Docker, that would be helpful. What kind of Docker we need to install?
Docker is fine. You have to just go
Any
and
Docker is fine. Okay.
this version of Docker. Get it installed. If you say Docker -- version, it should give me the Docker version. If I say Docker - compose version, it should give me the Docker compose version. That's it. If these two things are working, we are all good.
Okay, Shivang. I'll get it done.
Now, let's move to MLF. Okay, one question I have for all of you before I move to MLF. In fact, since we have a lesser time, let's start with streaming itself. MLF we will talk tomorrow then. So streaming, if I talk about, in streaming, what happens and how the things looks like. Okay, I will show you a demo also how streaming sort of works. So till now, all the processing what we were doing were belonging to your batch processor. What was happening? I have a bigger data. I collected it. On that data, I started working. Like same thing we did with Spark SQL, the same thing we did even in other components as well, right? Even when we are working with Spark Core or Hive, we already have the data and we were using it. But there are a lot of applications where we do not want to, we do not get the data historically. In fact, we are getting the immediate data and we want to take some action on that. Like I gave you an example of credit card, right? You're doing some credit card transaction right now in India. Within 2 minutes, the same credit card physically is getting swiped in US. That's not possible. So in that case, once they get the data, they kind of process it. They took their time and immediately blocked it. That is called the streaming of the data. Now, how things work with respect to Spark streaming? Now, though real time, we can still have it in Spark streaming, but we generally don't do that. If you think about the practical applications, have you noticed when you go and do some processing of your credit card? Let's say you went on a website and you said you put your credit card details and basically put your all the systems. Then it says that processing. It do a circle, it will say processing. And it also says that do not refresh this page or do not go back from this page, right? So why that processing part is happening means, is it not feasible that they will be able to give you immediate result? Because the data size is not that huge. If you think about Google, when Google is able to give you so quick result immediately on that, why can't banks could do that? Banks have all the structured data. Banks do not have that much of records what Google have. Then when Google can give so quick result, why can't bank do that? The reason is what they do is they maybe for the last 1 second data or 2 second data what you are given, they collect that. And on that 1 or 2 seconds data, they start doing some actions. Now, what basically it means is that you got your data, and so it's like this. Let's say you got all this data continuously coming up. Continuously, this data is coming up. But what you did on this data, you took maybe some portions of this data. So, for example, you said, okay, this is the last 1 second data. Let me take this up and start doing some processing on top of it. So why it did that? It's not basically you're gonna take all the data quickly and start working, but instead it will start taking the data like this 1 second chunk, 1 second chunk, 1 second chunk. So all the data coming up, it's waiting for 1 second at least. Let me get at least sufficient amount of data to start doing any processing. Otherwise, what could happen that if you will just keep on basically immediately data coming, you start doing some processing, it may not make sense. So definitely you need to wait for some time to have the meaningful data. Now I took an example of 1 second. It could be 5 seconds, 10 seconds, depending on the business case. For example, banks can go for even milliseconds. They can say, hey, for 1000 milliseconds, whatever records coming up in this packet, let me collect it. And those data I will do some operations. Or they can also say not with respect to time, but they can say, hey, all the data related to this customer ID, let me collect it. Let that all the data come together for this customer ID, and then I will do processing on that. So what is the main context here is that I would like to wait at least for some time, not for like very long time, but for some time, depending on your business case, to see that whether we have got all the relevant data. Because think about that. Let's say you just started sending the stream of data, and let's say for your customer ID, it have received only 2 or 3 items, not for all the items, and you start doing some processing. It will not make any value, right? You may miss out some important factor. So that's where we also, this is called as basically semi-real-time processing, you can also call it. Though you can still, when you're saying that, okay, I'm going to wait for, let's say, 1 millisecond or 1000 milliseconds for your business cases, definitely you're still going for the real time only. But it's not the exact real time. It depends again on your business case. For example, even right now, if you are also doing all this training, you are not viewing this in the real time. There is a slight lag. It could be a nanosecond lag, but there will be a slight lag. You are still watching it from your eyes also when you're watching your screen. It's going at the speed of the light, but there is a lag. It could be again, like I said, nanosecond lag, but there is a lag for you also to watch it out, right? So the lag is not going to be a bad thing. It depends on your business requirement. So that is what we will be doing with respect to your Spark streaming. Collect some information for the time duration you need, and then start performing some operations on it. Now, when I said let's say I decided to have a batch of 5 seconds. I said, okay, I will collect the data of 5 seconds, and that data of 5 seconds once I get, I will do some processing on top of it. Let's say I have taken this sort of decision for myself. So in 5 seconds, whatever data I have got, on that 5 seconds, I will create an RDD, right? So basically this green color first box will be one RDD. This second color box will another RDD. Third color box will be another RDD. This RDDs which we are creating of the shorter durations, we call it as D string. Okay, so this thing we call it as D string of the data. Again, a very important concept that D string, we divide it into small chunks and basically put it into different machines to execute them in parallel and get the result. So maybe this packet might have gone to one machine. Maybe think about it not with respect to time. Again, think about it, let's say for the bank who's, let's say, doing it based on customer ID. So now maybe this packet might have gone to one machine where it has created a small D string, and on that it did some processing. Maybe this packet is belonging to another customer ID, and this customer ID packet is going to some other machine, and it did some processing and gave you the result. So that's how even Spark makes it faster also. It is collecting that small chunks of data, and every chunk it can distribute it to the clusters and get very fast responses on top of it. So it is still creating RDD only in one way, but those RDDs what you're creating are smaller RDDs depending on the logic what you gave it to it. Everyone clear on this first component, which I just said? What is D stream? How Apache Spark works in terms of the streaming of the data? Okay, so that's number one. Number two, where Spark streaming is really strong at, which if I compare, let's say, with Strong framework and some other frameworks what we have, let's forget about Strong because I'm not going to talk about it, but where Spark streaming is hitting the nail. In Spark streaming, if you have the strangler nodes are the one which is taking a lot of time to respond. If you have the strangler nodes, then in that case, Spark streaming takes care of it really well. If it finds that some RDD or D stream is taking a lot of time, it will immediately push it to some other machine and take care of that automatically. You are not going to be bothered about that. The other frameworks which were there like Storm and all that, they were not able to do it. Okay, so Storm was actually really famous framework. Even now I've seen people using it. But Spark streaming basically at that point have done this work really well, and they basically have sort of resolved this problem of the strangler node as well. So you need not worry about all this. Like I said, it will be automatically taken care by Spark. It has some configurations of the time for which it waits. If you do not get a response, it just quickly accordingly take the actions for it. So that's another advantage what you get for this Spark streaming. Third thing is, we can also have something called as windowing operations on it. Now, what do you mean by windowing operation? Windowing operations will be something like, let's say, if I talk about Twitter. Now, on Twitter, what we generally do on Twitter programs, let's say if you are writing your code and, for Twitter, let's say you are collecting the data and so on. Now, if you have to see that Twitter gives a trending tweet to you, right? Now, Twitter do not worry about all the data which it have gotten, but instead it may be worrying only about the last 1 hour of the data. In last 1 hour, what all tweets have happened, what all hashtags have come for me, on that data, maybe Twitter will be interested to find out that, okay, what's the trending tweets based on that. It will do a word count, and accordingly it will give you the result that, okay, this is going to be the result basically for the last 1 hour of the data. So that's going to be another important thing which you have to keep in mind, that you can also perform these type of windowing operations. Now within those windowing operations also there are, for example, so there are 3 things to keep in mind. I will show you all these things practically in code tomorrow. Okay. Though I will not go in the Twitter code in detail, but I will be writing a code on Twitter and give it to you. You can run it later. Okay. And I will also show you how to run that on Apache Spark. Spark. Eclipse. I will show you that on Spark Eclipse tomorrow. Now, here, look at this, what I'm going to do. So there are three kind of timing operations. One is a batch processing, which I said, let's say you are creating this RDD of like 1 second size. Let's say you said 1 second is one state, second 1 second is second state, and so on. So the first one is the batch portion of it, right? That's the time, like what's the RDD size we are creating. Second is, what is the window size we are looking at? Okay, so let's say we said that we are looking at the window size of, let's say, 10 minutes. Okay, so 10 minutes window size is called as window size. So what I mean by that now? So if let's say this batch size, if I'm creating of let's say 1 minute, then in this window size, I will have 10 small RDDs. For 10 small RDDs, whatever the aggregated results I have, I will be considering that. Okay, so that is going to be a window size. So think of it in this manner. Let's say these all green colors are of 1 minute each. Let me little bit reduce the window size. Let's say I'm gonna say the window size is for maybe 4 minutes. Okay, so let's say this is coming for every 4 minutes. So what I'm going to do here is I'm gonna say my window size is this. So though I'm creating the batch size of 1 minute, but my window size in this case is 4 minutes. So in this 4 minute, maybe I'm counting how many words I have or whatever, right? So whatever in this window size for all these 4 RDDs are there, I will aggregate and give the result. That is called my window size. Another important thing, yes. There is also one more thing, sliding window. What do you mean by sliding window here? Now I'm doing this, but at what interval I need this? What I mean by that, so let's say I finished for these 4 seconds and then after that these 2 came. So let's say my this is moving in this direction. Okay? This is moving in this direction, which means I created this 4, then after that these 2 newly came up. How I'm basically going to count that up? So maybe I can create a sliding window of 2 batches, which means 2 minutes. What do I mean by that? So the next time when I will be computing this, my computation will look like this. So it will move by 2, and basically next time it will take the window of 4 lines. This is called a sliding window. What I mean by that, I'm not going to consider the last 2 which have came, but the first 2 I'm going to consider it in my computation. This is actually helpful when you are doing something like Twitter. So let's say they are doing it for 1 hour. So maybe they're also kind of overriding the last 30 minutes window also. So it's not like they're taking the complete new window to compute what's the latest hashtag, but they're also maybe for the maybe in 1 hour, whatever they got it. Then after that, they ignore the initial 30 minutes. Then they took the 30 minutes from the older data and 30 minutes from the new data. So like that, they're considering it back complete 1 hour. So that is, if that is the situation, we call this as sliding window. Everyone clear on these concepts? Because I'm going to use this in my code. So understanding of these concepts is important. So I talked about 3 timings. One is the batch timing. This defines my RDD size or D string size. Second, I talked about window size, which means that what is the appropriate size of the window I'm considering here. That's going to be important. Third thing is the sliding window, which talks about that what is in which duration you are looking for the window size. So if you make it, let's say 2 minutes in this case, then what it will do, it will just ignore the 2 minutes for you, means 2 minutes of the older data it will remove for you, and it will again make the window of 4 minutes for you. So that is what the 3 types of timings what we have when we talk with respect to Spark Stream. Everyone clear with this? Any questions? Okay. So now the first thing which I will do tomorrow is I will show you a code which will do a word count. When I say word count, what I mean by that, I will take a window of, let's say, 5 seconds. In that 5 seconds, whatever data will come as a streaming data, I will create a streaming data for you tomorrow. Whatever data will come like a streaming data, that data, it will be computing and give you the word count for it. Then after that, again, we will keep on giving the data in the streaming format with a medium, which I will explain you tomorrow. And then again, in that 5-second window, whatever data you will keep on giving as a streaming data, it will keep on doing the work on top of that and will keep on returning with the result as well. That's the first step will be good. Second step, that I will not be going into too much of depth, but I have written some code for you guys to give you an insight how you can do a Twitter streaming of the data, how you can bring the Twitter streaming of the data, and basically you can perform lot many operations. Like you will exactly create an application like Twitter, something like what are the famous hashtag tweets running in last 1 hour or whatever you want to decide on. So you can just change your parameters, it will work for you. So those kind of applications, how it's created, I will show you that code as well. That's the reason I explained you about this sliding window today itself. So I will show you that code. I will also show you how to run it on Eclipse. Maybe I will show you one code, how it runs as well. Once that is done, we will move towards the Spark ML. Clear, everyone? In fact, I have one question for all of you. How many of you do not know Spark, ML better, machine learning? Is there anyone who had no idea about machine learning?
Me, Shivang.
Okay, Aditi do not know. Anybody
For me
else?
also, yeah.
Shivang, are you asking about ML or ML?
Simple ML, not ML. Means, are you aware of data science activities? How it happens?
Yes, I am. Yes.
Fine. So I can see 2-3 people do not know it. That's completely fine. If you do not know it, I cannot go into depth anyway. But still, I will give you a good level insight how this works. And within that, I will explain you what is the significance of Spark ML, because that is going to be more important for me to talk here rather than talking about ML. And what I can do is, I can give you maybe the code for people who know regression, classification, clustering, how those codes are written across in Spark ML, and how you can run it with maybe, I can give you in PySpark, because I believe all of you might be using Python for your data science activity. So I will give you in Python. Will that be okay? And there will be again some 3 case studies which I will also give you. This is for people who know ML. People who do not know, they can skip that out.
Yes,
Yes,
Shivang,
Shivang.
that would be good.
Okay.
On streaming, I have a quick question. Like, can you tell me the difference between like Spark streaming, Kafka streaming, and Kinesis streaming, and when one should go for either of this? Like in which scenario I should opt for Kafka or Kinesis or Spark?
Yeah, I would suggest Girish hold on for that till the last class, because
Okay.
I will be talking on Kafka streaming. I will not go into depth of it, but I will also go on Kafka streaming. Right now, people do not know what is Kafka also. So
Yeah. Okay.
let's
Okay.
that, and once I cover it, I can also give you an idea on Storm and all that, so that you can distinguish between all of them.
Yeah. Okay.
Yeah. Any other question from anyone?
Yeah, Shivank, I have installed this Docker on the laptop. Can you tell me those commands?
Just say Docker version or Docker -n version. Just type that. Is it coming up?
Okay.
Actually, installing Docker is just a 5-minute thing.
Yeah.
It's very
Yeah.
small.
Right.
I just want to ensure that if you guys have some IT issues, it gets fixed.
Yeah, I think most of them don't have admin access. They'll need to approach IT team to get this Docker installed.
Yeah. So today you guys can do that. And this Docker will be helpful for you when you will work with the client also. Trust me on that. Some of the other client will come with a Docker. This is becoming the de facto now in IT industry. Even I do not know Docker earlier, but because of these clients coming up and asking to me, I have to read about Docker.
Shivang, small request. If possible, can you brief us what like how we can use and what and all in the Docker for 10 to 15 minutes, if possible?
Yeah, Gaush, I couldn't hear you clearly. Can you say a little louder?
No, if possible, can you just brief us the Docker also for 5 to 10, like 15 to 10 minutes?
Yeah, I will do that. Without that, you will not be able to understand my compose file, which I will show you. So don't worry about that. I will be making sure that I give you some time. If in case, if on that last day if required, I may extend the class by a few more minutes. That should be completely okay. I hope everybody's okay with this, right?
Yeah, it's
In
okay.
case,
Yeah, it's okay.
Yeah, Shiva.
so maybe the class can go till 4:30. Depends. Means if we are able to finish maybe by 3. Anyway, I really doubt we can finish in less than 4 hours because there are so many things to talk there. But at the same time, in case if we finish by 3:30, it's fine. Otherwise, it can go. It will most likely be spanning between 3:30 to 4:30. Again, and most likely it will be going towards 4:30 side. So if that's required, I can extend it a bit. But definitely, I will be first telling you a bit on Docker so that you guys have the idea about it. What do you mean by containers? How Dockers are useful, and so on. And then I will move to Kafka. Okay, I think then we are good. Let's connect tomorrow then for our last.
Where will we get the Docker image?
You can easily Google it and get that. So there is Docker Hub actually. If you want to go and get that, you can get it from there. There's a Confluent page also. From there you can get that. But it's you can just Google it. Downloading Docker, just give the name of your operating system. It will take you the exactly the same page and just download it. Or maybe Girish, you can help the candidates to install it.
Yeah.
But with the Docker image of Kafka.
That you leave it to me. I will give you that image. Okay. Don't install any other image like that because I will give you an appropriate image which I need for the class. Okay. So that you don't worry about, guys. Just get the Docker installed for now. Okay, then we are good. Thank you, everyone.
Yeah, thanks, you.
Thanks, you.
Thank you.